Hey guys, it's Ed from Lucky Hanger 13. I want to talk a little bit about my transponder. I bought the Appareo ESG transponder with the Stratus receiver on it. A little bit disappointed because, they advertise this as an ADS-B in and out solution, but it's actually only an ADS-B out solution. It's ADS-B in if you happen to use Foreflight, but Stratus, Appareo, and Sporty's Pilot Shop all kind of conspired to make some sort of deal with the devil that allows them to lock out the Stratus receiver from all the other electronic flight bags. I do have to admit my research into the matter was a little bit weak. I borrowed my friend's Stratus receiver, and it was an older version, worked with my electronic flight bag, so I thought, well, this could be the transponder I want. It looks like an ADS-B in-out solution, I'll run with this one, and then I found out that in fact it's not an ADS-B in-out, so I'm very disappointed with it. And the transponder itself is really a nice transponder. It's just the business model of the company actually selling it with the Stratus and not telling you locked to Foreflight only. They advertise that the Stratus is designed for Foreflight. Well, that to me says it's has some features that Foreflight uses that other electronic flight bags won't use, but in fact it just means it's been locked out and you can't use it for any other electronic flight bag. Very mean solution for the pilot community. It shows a definite disrespect of the pilot community, so I can't get behind it. I pretty much don't like it. I probably would not have bought the Appareo knowing what I know now, but I was able to get a solution that works for me, and it does look like an ADS-B in-out solution with my new wiring in of the Statux Raspberry Pi ADS-B in receiver. So I'm going to show you how I did that, and then if you have one of these Appareo transponders or you're considering one, you have options, and one option is don't buy the Stratus receiver because unless you don't absolutely need any options, you don't want any future options, you just want to use Foreflight and you're never going to use anything else, then the Stratus is probably a good way to go. It's your call. But I wanted to get to use the electronic flight bags that I actually use. So the Statux actually has a broad support. It's an excellent ADS-B solution. It works well for me. I've only seen one bad complaint about it. I'll have a discussion about that in the future. This is really about how to wire it into your transponder so it looks like an ADS-B in-out transponder. So this is the transponder that I got, and it is the Stratus ESG, and it comes with and it's marketed, like I say, as an ADS-B in out, but it's not really an ADS-B in. By the way, if you do want one of these, Guru Aviation installed it in mine. Guru Aviation is on my home field of Oswego County Airport. Top-notch outfit. They sell both the Stratus and the L3 transponder. And that was the other one I was considering, was the L3, but it was like over twice as expensive. And as my wife used to tell me, God bless her, you're so cheap, you always end up spending more money than you need to. And unfortunately, that is the case, because particularly in this case, because I basically had to throw away my ADS-B in Stratus receiver because it's of no particular use to me, since I do not use, and I just don't feel right selling that. If somebody actually just wants to use Foreflight and never use anything else, they have one of these transponders, you want to buy it, give me a call, I'll give you a heck of a deal on it. So otherwise it has no value to me, and I wouldn't sell it because I think selling something like that that's crippled in that manner is really bad juju. So the Stratus transponder, though, has a neat feature called the portable the portable connect feature, I guess. Yep. And it provides an antenna feed through for the ADS-B antenna, so you can connect it to the external antenna that the ADS-B in channel is not being used by the transponder. Yep. So it's not being used by the transponder, so they just pass it through and allow you to connect it to another portable ADS-B in solution. The transponder also provides 5-volt out. It also provides GPS out, but I'm sure they've coded that signal. They actually kind of mask it in the interface. I'll show that here in a little bit. This is the feature they have. They actually sell a kit called the Portable Connect Kit. You do not need to buy that kit unless you want to mount it outside. I mounted mine behind the cockpit panel. I did not want to have to hook it up outside or anything like that. I just want it in the plane, and I don't want to ever have to touch it. I just wanted to turn on my transponder and it works. And so far, that's what I got. So I do actually have what looks like an ADS-B in-out transponder. And I use this kind of neat feature that they offer, the portable connect feature. So one thing is, if you buy the Appareo transponder, I recommend, unless you're going to use the Stratus receiver, that or buy this portable connect or if you're not going to buy the Stratus or the portable connect, you need to have the Radio Shop wire in a DB9 pigtail that normally you buy with this kit. And then you can add any ADS-B in portable receiver that has an antenna feed. This is what it looks like on the back of the plane. Here you got a DB37, has all the signals and voltages out. And here is the antenna feed through. You can just connect that right through to an ADS-B receiver, and you are connected to the external antenna, and you should get awesome reception. The connector, the neat thing about the connector, they also provide 5 volts out to the DB9 that you're going to see here in the next connection, and that can be tapped into to allow you to power your Raspberry Pi. Now, I do want to share with you a little bit of my concerns. This is kind of sort of, once again, goes back to the bad business practices of Appareo, Stratus, and Sporties. These, if you look these up in the previous connector list, they say they're 5 volts, aux 5 volts. But here it looks like some sort of differential signal, serial signal. I don't know if that's the GPS signal that they're providing out. I'm sure it's coded so that nobody can read it. Otherwise, we could actually rewrite the software a little bit on the Raspberry Pi to take that as a GPS input. They do not give us any information. They hide it because I guess they're interested in stiffing as much as they can. So the aux ground is pin 18. So you can pull your power off of your DB9 connector by tapping into 1 and 8 and running that to your Statux receiver. If you don't buy the portable connect or you don't buy the Stratus, just make sure that the avionics shop that does your installation installs this DB9 connector wired in this fashion. Here is the RF out. You saw that in the picture. You just run that right into your ADS-B receiver, and you are connected to the outside world. So it's a neat path. It's a neat solution. I think the Appareo is the only transponder I know that actually does this, but it's a neat feature, and it saved my bacon. Otherwise, I'd just have an ADS-B out solution, and I would probably be pulling it out and putting that L3 in. I've actually already considered that, but I'm going to use this for a while and make sure it works okay. If it works okay for me, I'm living with it. Otherwise, I'm going to spend $6,500 on that L3 transponder. I don't want to move ADS-B in receivers around. I don't want to plug them into power. I just want to be able to turn on my transponder and make it look like it's an ADS-B in-out transponder, like they advertise this one to be. Here's a picture of my configuration that I use. There's my Stratus receiver. I've already pulled it out of the airplane. Actually, I've already got it all installed now, and it works great. I've already got this Statux installed, and it actually works wonderful. The downside is I have to put this GPS puck, once again, if they bothered to share with us that interface, which I know they won't, because they don't seem to know much about it. None of the people have been very helpful about this at Appareo. I had one fellow who told me about that interface, and after that I was on my own to come up with a solution. And this is what I came up with. I have to mount this on my dashboard. I take this connector here and plug it into the end of the transponder. I feed it in here. It just takes the same signal and splits it 2 ways. This is a 978 port on the Statux. This is the 1098 port on the Stratus, and this just takes the signal in and splits it. I use this passive splitter here, which will actually add 3 dB per, loss per channel. Because you're splitting the signal, there is no loss in the splitter, but because you're taking the signal and splitting it in half, you're getting 3 dB less. 3 dB is decibel for half power, so you're getting half the power out. Here are some smaller. This is like $20. These are like $10. These are small resistive splitters, and they're resistive, so you get the splitter loss, and then you get the resistor loss. Turns out to be about 6 dB per channel. So you can use this. I think either one of these is a good solution. I believe this has this wired in there. I opened it up and looked at it. We'll talk about that in a future review. I believe they're using this. So you're going to probably get less RF performance with this unit than you will with this one. So installing it in this fashion should give you better performance, I believe, than the Stratus receiver. And I plan on actually have what I ended up using. This has a DB9 to a USB Type C connector, and so I bought a USB Type C to a USB micro converter. And sure enough, they didn't rewire that pin. That if they really wanted to be mean, they could have rewired that so that you couldn't use it. But I don't think that they figured that out, so they just gave you a straight USB port, which, you know, kind of worked in my favor because I could put that adapter in there and I just plug it in here and I get the 5 volts out. So, but this was the cable, you know, I planned on just cutting off the end and putting a DB9 here and plug it in. I will likely do that anyways. I'm going to pull out the Stratus cables as well come my next annual in August. It's just, I can't get behind there to do all that. It's all been tie strapped and looks pretty back there, and you know, I really can't get back there and do that without taking out some of the radios. And we'll get behind the panel during the next annual, and we'll go ahead and pull those out and put my own home fabricated cables in place. So that's the solution I'm looking for. I think it's really works really well. I get good reception, and I can use any electronic flight bag, almost any electronic flight bag in existence. If you want to build a Statux receiver, if you want to wire your Statux receiver in, these are some links to some parts that you can buy: the cables and the splitters and BNC to SMA jumper that you would need. So you're going to need a BNC that plugs into the transponder to an SMA, which, you know, any of these splitters use an SMA. Or you can go straight from BNC to SMA right into the Statux receiver if you only want the 978 channel, which will give you the government weather and targets from the FAA towers. But if you want transponder replies too, you'll want to split the signal somehow, and you want to split the signal and run that here. I want everything I can get, so that's why I'm doing the signal splitting. All I really need is probably this 978 feed right here, but like I said, I want everything, so you know, I've got the splitter in there. I did that. So this tells us where you can go buy those, you know, a DB9 to micro USB cable, DB9 to micro USB cable to give it power to your transponder, and then these the splitter, the jumpers that go from the splitter to the Statux receiver, and then the transponder to the splitter. A word of warning, you know, I've seen lots of pictures on the web, people doing this, so they'll put this Y cable in place here and run it over into each of the 2 different software-defined radios. You know, basically what you got is a 50 ohm cable going into here, and it's splitting into 2 50 ohm cables, which in parallel look like 25 ohms. So that gives you a dreadful loss at this interface right here. You're going to get 3 dB for splitting the signal, and then the loss from going from a single cable to a Y cable is about 10 dB. And I calculated that out. If I did it wrong, you guys go back and calculate it, and please leave a note down below. Tell me, hey, you calculated that wrong. But it looks to me like you're going to lose 13 dB per channel to do this. Now, I do want to share with you, you know, if you're here in the Northeast, you know, or actually anywhere along any of the coasts, looks like the coasts are pretty well covered in America. A lot of the middle is covered too, particularly around big cities. But you can see there's some sparse areas in here where there's not much coverage. You know, you might not notice this terrible configuration in an area here where you're flying from one tower to another tower and passing a tower. You know, you got lots of coverage there. You can probably afford that loss and still pick up ADS-B targets, but your range will be severely limited if you get too far from any one tower. You know, a 3 dB loss. So because we do everything in power, we do all these calculations in power. So when I say 3 dB, that's talking about we've reduced the power. But the receivers sense voltage, and the voltage is the square of the power, you know, times the resistance, you know, times our V squared over R. But so you know, the voltage is the square of the receiver, and then the path loss, the, you know, free space loss from the tower to your airplane also is the square of the distance. And because those are squares, they basically, you know, one is directly proportional to the other one. So the 3 dB loss, you're going to lose about 29% of the total range if you just ran one signal in to one radio. So if you run one signal in without splitting it, you'll get 29% better performance than using this very nice high quality splitter that will give you 3 dB because you're splitting the signal. You know, you're not losing, there's no passive losses in this thing. You're just splitting the signal, and so you're losing half of the power because you're sending half one way and half the other way. So when you do all the calculations, you find out that you get a 29% reduction in range from optimum if you're not using, if you're not splitting the signal. If you use one of these little passive resistors, these passive splitters, you're going to lose 6 dB of loss, and so that'll reduce the range about 50%. So, you know, that's probably okay. It's probably the system was designed to support that. I don't know anything about the tower power and all that kind of stuff, but if anybody has that kind of information or a link to that, post it down below, and I can actually maybe do some link calculations and estimate the performance, RF performance of these various receivers. Now, if you use a Y cable, you're going to lose up to 78% reduction in range. You might not have an issue with that over here in the Northeast or over here on the East Coast or the West Coast, but out here in the middle, you may notice that. So, you know, not a good solution. I've seen people do this. They're like, hey, I get targets. Yay. Well, yeah, you'll get targets, but, you know, if you're flying, you know, too far from a tower, you're going to just lose the tower. And likewise, you will probably have issues with picking up external transponders from other aircraft as well. So I just want to be careful about that. This Y looks easy and it looks like a nice way to do it, but it's from an RF perspective, it's a bad idea. To be honest with you, when I opened up the Stratus receiver, I could not see the passive network that was splitting things. I'm thinking they must have built it into the connector, or they're doing one of these Y connectors, or they numerically design the traces leaving so that they look like 50 ohms. That would be really hard to do, so I don't know if those guys did that. I mean, you can do it with numerical analysis tools. You can't do it with hand calculations, I wouldn't think. But I could not see a resistive network. I could not see inductors or capacitors, so there's no passive network. There's no passive resistive network. You know, I'm thinking the Stratus may actually just be doing this, and maybe that's okay. Maybe you get sufficient performance. You'll get better performance using my solution with the splitter. Or I have another solution. If I lived in one of these areas here where there's sparse connectivity, I would probably do something different. I would probably go straight from the transponder into the 978 channel, and you don't incur any losses. It's just a cable loss, which will be a few tenths of a dB. I don't think you'll notice much of a range reduction there, but you know, you will get optimum performance with that configuration of 978. The problem is you won't have the 1090 transponder to transponder replies. So the other thing I would do is I would add one of these little monopole antennas and put it on the dash next to my hockey puck. So that would give you optimum performance. If I lived in one of these areas here where it was fairly sparse, that's what I would do. I would live with that little antenna on top of my dash panel and wire it directly into the 978 channel for optimum performance. That's going to give you the best performance of anything. So the other thing you might want to do is if you want to use one of these antennas, it's a monopole antenna, so it's really intended to be mounted on top of a ground plane. And, you know, it doesn't have to be a big ground plane, maybe 3 inches in radius, 6 inches in diameter. You can even make it a little smaller than that, I suppose. But you'll get 3 dB more performance by putting that on a ground plane. So you'll be enhancing the performance pretty substantially for transponder to transponder replies. And maybe you don't need that much, but you know what? It's a monopole antenna. It's supposed to be mounted on a ground plane. I would just put something underneath it, copper or aluminum, and I would probably put it on the bottom side of the dash panel so you can't see it, and that would work just fine. So that would give you, this is the optimum performance configuration for, for operations in areas with reduced ADS-B tower coverage. Now, for these areas here, when you're in these white areas, you'll get all the transponder replies when you're flying next to an airplane with a transponder, but you won't get the tower replies. The tower replies are the blue areas here. So, like I said, if I lived in one of those areas, this is the configuration I would have in my plane, because I'm always about max performance, I suppose. So, kind of sort of some of the recommendations, I'm real pleased with this setup. I am actually very happy. It looks like I have an ADS-B in-out transponder, so I'm okay with it. Because they sell the portable connect feature, I'm assuming it's perfectly legal to wire any portable in there. So that's what I do. I wired this particular one, and like I said, I'm real pleased with that performance. But, if you're interested in, getting yourself a transponder, just a couple of words, ADS-B in-out transponders or portable solutions, just a couple of suggestions, do not get a receiver that limits your EFB options. So the Garmin GDL39, that's pretty much a Garmin Pilot thing. I mean, it's a good thing. Garmin Pilot's actually reasonably priced, and the reviews and trading sessions I've done on those seem to be really, really good software package, at least as good as Foreflight. So I can understand you wanting to go with a Garmin GDL39 if you have a Garmin panel, but generally speaking, you're limiting yourself to, in that case, Stratus. I believe it'll also support Foreflight. So try, myself, I've never been one into limiting my software options. Software is the powerful part of any piece of hardware, so my suggestion, if you need a Stratus, if you think that's the thing for you, go for it, buy it. Tons of them on the used market, because some people realize that they can't be used for anything, but that they actually try to dump them on the market. A lot of people upgrade their airplanes and have ADS-B in-out solutions, so they sell them then as well. But, myself, I'm skipping that. Probably will never buy a Stratus anything again. All they sell are ADS-B in receivers. Someday they may start selling other avionics, and I absolutely will not buy anything unless they change their business model to not be so mean to their customer base. So Statux is the price performance. Oh my God, you can build one for like $130. I've put a Word document down below with a bill of materials. You can link on any of those links to go see the parts, and then search similar parts. And then the external antenna really, really, really helps get you optimum reception. So really a neat solution. I do like the Appareo transponder. I got what I bargained for because I was able to wire in another portable solution. It looks to me, as soon as you turn it on, I can start getting targets if they're out there, and it looks just like I have an ADS-B in-out transponder. So, probably the lowest cost ADS-B in-out transponder that you can get would be this Appareo ESP. Don't buy the Statux with it. Don't buy the portable connect. You can build it cheaper than you can buy it from those. I think it's like $100 or something, but you can actually build it. All those parts you saw were like $30, so I could build the whole thing for $30. Not counting the receiver, which is about $150. If you wait at the right time, Sun and Flan or Oshkosh, they put those on sale all the time for $150, which, to be honest, you can barely build it for that cost. So a lot of Statux knockoffs. They have, I think, the Merlin and some of the others. They're basically Stratus knockoffs. There may be some value added. They may have done some things to the software and whatnot, because it's all open source. They even offer you you can even go download the software and do your own build, or you can download the latest build and flash it on your own memory card. Or you can just buy the memory card, So I have that in the link below too. If you buy a memory card that's blank, it's about $10, and if you buy one with the Statux software already burned on it, it's $15. So if you don't know how to burn that software, it's probably worth $5 to you not to have to learn it. So I've been using the Raspberry Pi computer for a long, long time. I got a weather station that's about half built, and I got a security system that's about 20% built. So I burn a lot of those little chips and stuff for my Statux, for my Raspberry Pi computers. And if you have other recommendations, please post them below and let us know what you thought. I'll certainly read them. I'll certainly take a look at what you got, and hopefully this was helpful for you. Some good solution paths here. If you're in a sparse area, you're never going to get more performance than this right here, and probably an Appareo transponder. If you live on the East Coast, this is a really awesome solution. I'm betting this is a better solution than the Stratus in terms of RF performance, but I really don't have the tools to evaluate that, because I definitely don't have Foreflight, and I don't see it in my near future. So there's the installation, guys. I got it sitting here on a vibration pad that's very sticky. I used a USB-C, oh, here it is, USB-C to micro USB to convert the output. I wasn't certain if they rewired the USB-C, but they apparently didn't. Well, I don't know if they did or not, but they powered it up and it powered up. So just using the standard cable that came with it. So yep, there it is, ADS-B in, using a Raspberry Pi Statux receiver. So guys, hopefully this was helpful. If you liked it, thumbs up. If you hated it, thumbs down. Let me know your thoughts. Post them down below. And thanks for listening. I appreciate you. And we'll talk soon.